Okay, so we're going to start looking at Earth's atmosphere. This is going to be page 5. It's the back of page 4, the back of the water cycle notes. How does increasing altitude affect air pressure and density? What are the 4 main layers of the atmosphere, and what are the characteristics of each layer? All right, first off, we're going to flip to the anticipation guide, 3 and 4. On the left-hand side where it says before, write true or false, even if you don't know. Make a best guess. Maybe you do know. Number 3, the exosphere layer of the atmosphere is where weather occurs. True or false? Number 4, it is hard to breathe as you go up in elevation because the air is more dense than at sea level. True or false? All right. So, first thing we're going to start talking about is air pressure. So the one thing you may not know is, air pressure our air has mass, so it does have a little bit of force, which means those molecules actually do push on you. If you have sensitive sinuses, every so often you may feel like get a sinus headache. That's because the air pressure is changing, and typically a front is going to come through. We'll get into that later this year, or later this topic about that. But just know that, there is pressure, and it can sometimes affect people. How can we measure pressure? There's a thing called a barometer. A barometer measures the pressure, and this is just one type. This is a mercury adiabatic type, and then there's another type where you use mercury or something like that that measures it liquid-wise. Your toilet is kind of like a barometer too, because you'll see it move up and down depending on the pressure. Yep. Okay, off of that, we're going to get to, we know that air has pressure. We also know that there's altitude. Altitude's a little bit different than elevation. Elevation is how high up you are on the ground, whereas altitude is how high up you are in the air. It's the distance above sea level, too. And there's a relationship. As altitude increases, as you go up in altitude, the air pressure, it goes down because there's less air up there, so there's less of it. It's not as dense, which is why it's more difficult to breathe the higher you go, which, if you've ever heard about Mount Everest, they have to take stops as they go up because they have to normalize their breath because there's less oxygen for them to breathe in. There's less air for them to be able to breathe. It's less dense, so their body has to get used to it. All right, density, I brought this up. So one of the things about density is at sea level, right there, where the sea meets the land. This is where at 0 altitude, there's like no air above it. It has the weight of the atmosphere pressing on it. And this is where it's going to be the highest. So it's going to be the most dense at sea level, less dense as you go up. All right, and then we have this lovely little atmosphere. This is a great picture. It may help you out in coloring and defining things a little bit later. The atmosphere, it is a blanket of gas. It's just a whole bunch of gases that surround the Earth, which weirdly enough, nitrogen makes up most of it, not oxygen like you would think. There are 4 different types of layers with varying according to altitude and temperature, and some of those layers have layers in them. All right, so the first layer we have is the troposphere. It's the closest one to the ground, and that's where you're going to find all the weather. That's where you're going to find all the wet, the rain, the precipitation. That's all of it. And yeah, you see a plane there. They lift up, they go from here and go out. But you'll also notice that sometimes with clouds, that there are different layers of clouds. Yes, there's different layers in the troposphere that the clouds kind of hang out at. Like right down here, and this one goes all the way up. This is like a really, really nasty storm, by the way, like where tornadoes come from. And then we have the stratosphere right here. And you'll notice there's 1, 2, 3 flying things in the stratosphere. So this is where planes go. And this is also where our lovely ozone layer is right there. This is very important. This ozone layer protects us from ultraviolet UV radiation. And if we didn't have it, that'd be like really, really bad. Think of like your sunblock not working. Then we have the mesosphere. This is up here. You'll see this, and the rockets go through it. But these right here are very important. Those, this sphere protects us from meteoroids. This is where the vast majority of them burn up. And that's a good thing. You want them to burn up. You don't want them all to crash and hit the Earth. Otherwise, we'd look like the moon. And then last but not least, we have the thermosphere, which actually is split into two things. You have the ionosphere, which we're going to talk about first, and then you have the exosphere. So the ionosphere, this is gas molecules are electrically charged, allowing radio waves. So if you still listen to radio like I do, this is how we get our radio waves. There's certain antennas. That's what they transmit using. And then you have the exosphere. So the exosphere, this is where your phone calls, your television pictures, they're relayed by ways of communication, aka satellites. Satellites hang out up here. So all of our transmissions hit off of that satellite. So just a rehash of what we're looking at. Troposphere, this is where you get the weather. Stratosphere, that's where all your planes and everything. Mesosphere, you're going to have your meteoroids. Thermosphere, in the ionosphere, that's going to be your radio waves. You're also going to see the aurora borealis, or the northern lights, because those are electrically charged. What you're seeing is electrons being charged, and that causes the aurora borealis. And then you have the exosphere. It's where satellites hang out and orbit the Earth. That's also where the spaceships orbit the Earth. Quiz time. All right, get out a blank piece of paper. This would be quiz 2, atmosphere. 1, 2, 3, 4, 5. Which layer of atmosphere is where the planes fly? Is it the troposphere, stratosphere, mesosphere, thermosphere, or exosphere? As you increase in altitude, air pressure does what? Does it increase, decrease, stay the same at any altitude, or depend on the time of year? Describe how temperature changes are as altitude increase in the troposphere. So, as you go up in the troposphere, does temperature go up as altitude goes up? Does temperature go down as altitude goes down? Does temperature go down as altitude goes up? Or do they remain the same? In which atmospheric layer are the satellites that allow you to watch live sports and football? Where do that hang out? Is it the exosphere, troposphere, ionosphere, or mesosphere? Last but not least, why is it harder to breathe when you're higher up in the mountains? Is it because gases become thinner the higher you go? Gases become thicker and the higher you go, the atmospheric layers change, or the air pressure increases? All right, let's go back to 1. Which layer of the atmosphere are where planes fly? This should be the stratosphere. As you increase in altitude, air pressure decreases. This one, you had A going like this and B going like this. That is the same thing, same as this. What is my odd one out? So temperature will go down the higher you go. It gets colder. Think of like mountains. Like at the bottom of the mountains in the think of Mexico, Arizona area. They have the bottom of the mountains. It's dry, very deserty like, but as soon as you go up the mountains, you start to see snow. That's a good example. It's hotter on the bottom, colder up top. In which atmospheric layer are there satellites? Where are the satellites? That's the exosphere. And why is it harder for you to breathe the higher you go up? The gases get thinner, less dense the higher you go up. All right, let's go back to the anticipation guide. The exosphere layer of the atmosphere is where weather occurs. True or false on the right-hand side? This would be false. The troposphere is the closest layer which has the weather. It's harder to breathe as you go up in elevation because the air is more dense than the sea level. It is the most dense at sea level. As you go up, it becomes less dense. All right, let's flip to the summary, back to page 5. How does increasing altitude affect air pressure and density? As altitude increases, air pressure decreases and the density of the gas decrease. What are the 4 main layers of the atmosphere? The atmospheric layer closest to the Earth is the troposphere. Then you have the stratosphere, then the mesosphere, then the troposphere. The thermosphere. My bad. Okay, what are the characteristics of each? So the troposphere has weather. The stratosphere has airplanes and the ozone layer. The mesosphere protects us from meteoroids. And the thermosphere has the ionosphere and the exosphere, which help relay signals back down to Earth. All right, so that's it for the notes. If you have any questions, please let me know, and I hope you guys have a great day.